So really what we did on page 205, we were about 80% done with the writing of the reactions. So now we just have to show it with the electrons in there. So here we go. So first thing, assign oxidation numbers based on the reaction that you are given. So start there with assigning oxidation numbers. Element, 0. H bonded to a nonmetal, +1. Cl has to counterbalance, -1. We have a compound, Na, group 1 is a +1. Cl needs to supply enough to cancel it, -1. H2, diatomic element, assign it a 0. Next step in this is eliminate spectators. Spectators do not show up in the half reactions. So find anything whose oxidation state on the left is the same on the right. So that would be the Cls. Now, oxidation. Remember, that is the Leo process. So we losing electrons. So that means that we lose negative charge. So we see an increase in the oxidation state. Reduction, that is your GER process. Gaining electrons, gaining negative charge. So we see the oxidation state going down that ladder. Use those to your benefit. So here we go. Let's just kind of start where we did on the previous page. Na starts off with an oxidation state of 0 and it ends with a +1. So Na's oxidation states went up the ladder. So I know that the Na's are participating in the oxidation process. Okay. I'm going to move down and just get my information down. I see that the hydrogen starts off with a +1 and it ends up with a 0. So its oxidation states went down the ladder, so it must be going through the reduction process. So I start off with H +1 and I move to H0. So we have a good start here. I'm going to keep it simple and stripped all the way down. I'm not going to worry about coefficients or subscripts in just learning the foundations of this idea. Now, the other idea here is that whatever the total charge is on the left, it has to equal the total charge on the right. And if they aren't naturally balanced, we add electrons, negative charge, to help balance it. So here we have a charge of 0, we have a charge of +1. Well, +1 is a greater charge than 0, so I'm going to add 1 electron here. So now I have a +1 plus a -1, which equals 0. So now my total charge on the right is 0, and my total charge on the left was already 0. I need to do the same type of analysis for my reduction reaction. So right now, my total charge on the left is +1. My total charge on the right is 0. +1 is a higher charge. I need to bring it down to have the same charge as 0 on the right. So I'm going to add an electron. So if I add an electron here, 1 electron, -1 plus +1 equals 0. My next bit here is I need to make sure that the number of electrons lost is equal to the number of electrons gained. And so here we go. This is showing 1 electron being lost versus 1 electron gained. So these are balanced between them. Looking at the next example here, I need to assign oxidation numbers. I have hydrogen bonded to a nonmetal, so it's using a +1. There are 2 of those hydrogens, +1 each, so they supply a +2 total. I have 2 of the partner that needs to balance it out, so those 2 partners are each using a Hydrogen bonded to a nonmetal. The hydrogen is using a +1. There are 2 of them, so that's a +2. I only have one partner to counterbalance that +2, so it must be using a -2. And my last formula, there's only one symbol in it. It's an element, so I assign it a 0. So I went through and assigned oxidation numbers. Now I need to take a look and cross off spectators, right? So H starts with a +1, ends with a +1. Spectator, it's not participating in the electron transfer. The crazy thing is this leaves me with only one species on the reactant side. So here's the crazy thing. Some of the oxygen reactants end up with the water, and some of the other ones end up in the element oxygen. So in this process of what's being oxidized and reduced, we're starting off with the exact same species. Oxygens using a -1 charge. Well, let's just remember our terms. Oxidation is LEO, lose electrons, lose negative charge, so your oxidation number becomes more positive, goes up the ladder. Reduction means gain electrons, gain negative charge, so your oxidation state is going to reduce to a lower value. Well, so -1 to go up to a -2, that's going down the ladder. So going from -1 to a -2 is down the ladder. So that's our reduction. -1 going to a 0, that's climbing up the ladder. That's our oxidation state, or our oxidation process. So now we've identified what's being reduced, what's being oxidized. But when we take a look at this process, on the left, my total charge is -1, and on the right, my total charge is 0. So 0 is actually the higher charge. I need to bring it down. So the only way I can bring it down is by adding 1 electron. So my electron's -1 charge plus 0 leaves me with -1, which equals the -1 on the left. In the reduction process, my left's total charge is -1, the right is -2. -2 is a bigger value, or going down, so I need to bring the -1 more reduced. So I have to add an electron to the left-hand side. So -1 plus -1 equals -2, and I already have a -2 on the right-hand side. Taking a look in this, my oxidation shows a loss of 1 electron. My reduction shows a gain of 1 electron. So the electron transfer is balanced. Last example here. So the nice thing, oxidation states have been assigned, spectators left out, so I'm going to go straight to my analysis. So once again, oxidation means that is LEO, lose electrons, lose negative charge. You're climbing up the ladder, ending with a higher or more positive value. Reduction, gain electrons, reduction, gain electrons, gain negative charge, means that your value, your oxidation state is going to go down. So let's do our analysis. We're starting off with Na. We understand it starts off as a 0 and it becomes +1. So Na oxidation state climbs up to a +1, so it's going up the ladder. That's the LEO. So we're going to put Na0 to Na +1. Now the Mg starts off with a +2, and we understand at the end it becomes a 0. So we go from +2 down to 0. We went down the ladder. That's our reduction process. Okay, so now let's take a look at each half reaction's total charge. In the oxidation, Na charge is 0 on the left, +1 on the right. We got to bring that +1 down so it matches the 0. So we add an electron. So -1 from the electron plus the +1 from the cation, our total charge is 0, which now matches the left-hand side. In the reduction, the reactant side is a +2 and our product side is a 0. So the magnesium +2 is the higher charge. We need to bring it down to 0. We do that by adding electrons. But if I add 1 electron, +2 plus -1 equals a +1. Still not 0. So that means I'm going to add another electron. So I'm going to put a coefficient of 2. So now I have 2 times the -1, so -2 charge for the 2 electrons, plus the +2 from the magnesium. That sums up to 0. So my left side's total charge is now the same as the right-hand side. Next thing I have to look at is my oxidation process is only losing 1 electron, but my reduction needs to gain 2. So now we have to balance the number of electrons. So the number of electrons lost must equal the number of electrons gained. So if they don't naturally equal, we're just going to keep this simple. We're going to put brackets around the half reaction as the lesser number of electrons and figure out what to multiply through by. So I would multiply everything in the oxidation reaction through by 2. So that I end up with 2 electrons lost to 2 electrons gained.